Hello and welcome to Priority Learning series on worksheet solutions where we solve all of our worksheets on video for you to work through. So as always, this worksheet can be found at prioritylearning.co.uk. Today's worksheet will be looking at prime numbers. Question 1a. Define what is meant when a number is prime. A prime number is only divisible by 1 and itself. So that is the dictionary definition of a prime number. We can only divide it by 1 and by itself, no other numbers. Part B gives 3 examples of prime numbers below 20. Now the number 1 is not a prime number because 1 is itself, so it doesn't fit the definition. The first prime number below 20 is 2, then 3, then 5, then 7, not 9 because we can divide it by 3, 11, 13, not 15 because we can divide it by 3 and 5, 17, and 19. Any of those 3 numbers would be an acceptable answer. Part C, what is the first prime number that is greater than 100? The answer to that is 101. Nothing goes into 101, so there's no quick fire way to check this. We know that 101 is odd, so we know that no even numbers go into it. It doesn't end in a 5 or 0, so 5, 15, 25, 35, etc. don't go into it. We know that no multiples of 10 go into it, so we'd have to try 3, 7, 11, 13, 17, 19, and if none of those go in, we're pretty safe that 101 is prime. If this was an exam, I would recommend just trying 3, well we know that 5 can't go into it, 7, 11, maybe 13 if you have time. We don't need to try 9, because if 3 doesn't go into it, then 9 doesn't go into it, because 9 is a multiple of 3. Question 2. What are the prime factors for 36? And we need to write our answer using index notation. It's standard exam practice to write your answer in index notation. The question might not always tell you to, but it does expect you to. 36. So we'd solve this using the factor tree. 36 is even, so we can split that up into 2 and 18. 2 is prime, so we circle it. We can split 18 up into 2 and 9, and we can split 9 up into 3 and 3. So we could say 36 equals 2 times 2 times 3 times 3. We multiply all of these circled numbers. 2 times 2 is the same as 2 squared. 3 times 3 is the same as 9, which is 3 squared. So we write 2 squared times 3 squared. 2 times 2 is 2 squared. 3 times 3 is 3 squared. Now we'll have a look at 82. 82 again is even. So we divide it by 2. Half of 82 is 41. We circle the 2. Now 41, well 3 doesn't go into 41. We know that because 3 goes into 30. And we have 11 left. And 3 doesn't go into 11. 7 doesn't go into 41 because we go 21, 28, 35, 42. We know that 5 or 10 can't go into it because it doesn't end in 0. 5 can't go into it because it doesn't end in a 5 or a 0. 17 does not go into it. That might be a potential guess because 17 times 2 is 34. So we're pretty confident 41 is prime, so we circle that. So we'd say 82 equals 2 times 41. And this is in index notation. This is as simple as we can write it. 168. It's even, so we divide it by 2. Half of 168 is 84. Half of 84 is 42. Half of 42 is 21. 21, at first glance, might appear prime, but it isn't, because it is in the 3 and 7 times table. So we split 21 up into 3 times 7. So we can say 168 equals 2 times 2 times 2 times 3 times 7. So 2 times 2 times 2 is 2 cubed, times 3 and times the 7. That is now in index form. Next we'll do 315. Now, as I've mentioned previously, 315 ends in a 5, so we know that 5 goes into it. The tough part is, without a calculator, figuring out how many times 5 goes into 315. The answer would be 63, and if you're not sure, either check with a calculator if you're allowed one in your exams, or use the bus stop method. 63, again, may at first appear prime, however it is in the 9 times table and the 7 times table, and also the 3 times table. We'll split it up into 7 and 9. 9 we split up into a 3 and a 3. So 315 equals 3 times 3 times 5 times 7. We always order our numbers from lowest to highest. 3 times 3 is 3 squared, and then we times that by the 5 and the 7. So that's our answer. Question 3 is work out the highest common factors for 8 and 46. Now for smaller numbers, it may be obvious what the highest common factors are. For this one, I'll use the short method, which is just basically trial and error. I'll also outline the longer method, which we'll have to use for the harder questions. So, what are the factors of 8? Well, 8 goes into 8, but 8 does not go into 46. 4 goes into 8, but 4 does not go into 46. The next highest number is 2. So the answer would just be 2, by trial and error. However, we notice this question is 3 marks. That there would not carry 3 marks of working. So we should read into the question. This will require some more working out. So what we do is we use factor trees to split up 8 and 46 into products of their prime factors, then use something that I call a factor table. So we'll do 8 first. So 8 we split up into 2 times 4. 4 we split up into 2 times 2. So 8 equals 2 cubed. So it's 2 times 2 times 2. We'll do the same with 46. Split that up into 2 and 23. 23 is prime. So 46 equals 2 times 23. Now it's not immediately obvious where to go from here, which is why I like to construct the factor table. What I do for the factor table is I write the bigger numbers down the side of it. So 8 and 46, those are our two numbers that we're trying to find the highest common factor of. And then across the top I write the factors that appear in both of them. So we have 2 in both, and we have a 23 here in 46. So we write 2 and 23 along the top. We then draw our table. And we use the table to figure out the highest common factor. And the way we do that is by writing the type of 2 that goes into 8 and the type of 23 that goes into 8. So the type of 2 that goes into 8 is 2 cubed. There is no 23 in 8. So for the factor table method, if the number doesn't appear, we write a 1. And the reason for that is because we go across in the factor table. So 8 equals 2 cubed times 1. So if we wrote a 0, that would be saying that 8 equals 2 cubed times 0, which we know that it doesn't. We do the same for 46. The type of 2 in 46 is 2. The type of 23 is just 23. For the highest common factor, we pick the smallest number in each column, excluding the top row and the leftmost column. So we're only interested in the numbers that we've written here for 8 and 46. So the highest common factor of 8 and 46 equals, we pick the smallest 2, which is just 2, and then the smallest number in the 23 column, which is 1. So 2 times 1, which is 2. So this here would gain all 3 marks. It may seem unnecessary to go through all this just for the simpler questions, but it does outline the method, and when we get to harder questions, we'll see how useful it is. So 100 and 180. So we'd start off by writing them both as a product of their prime factors using the factor tree method. So 2 and 50, 2 and 25, splitting the 25 up into 5 and 5. So 100 equals 2 squared times 5 squared. 180. We split that up into 2. And 90. We split 90 up into 2 and 45. We split 45 up into 9 and 5 and 9 into a 3 and a 3. So that gives us 2 squared times 3 squared times 5. So 180 equals 2 squared because it's 2 times 2, 3 squared because it's 3 times 3, times 5. We then construct our factor table. So on the left hand side, we're going to be writing 100 and 180. And across the top, we write all the factors that appear. 2, 3, 5, 2 and 5. So across the top we need to write 2, 3 and 5. 2, 3 and 5, and then down the side 100 and 180. The type of 2 in 100 is 2 squared. The type of 3 in 100, well there is a 1, so we write a 1. The type of 5 is a 5 squared. The type of 2 in 180 is 2 squared. The type of 3 in 180 is 3 squared. And the type of 5 in 180 is just 5. So now for the highest common factor of 100 and 180, we pick the smallest number in each column as normal. 2 squared is the smallest number in the 2 column, they're both 2 squared. The smallest number here is 1, and the smallest number in the 5 column is 5. So 2 squared times 1 times 5, 2 squared is 4, times 5 is 20. So the highest common factor of 100 and 180 is 20. Next, we look at 36 and 136. Again, we write them both as a product of their prime factors. 36 we split up into 2 and 18. 18 we split up into 2 and 9. 9 we split up into 3 times 3. So that gives us 36 equals 2 squared times 3 squared. 2 times 2 is 2 squared, 3 times 3 is 3 squared. 136 we split up into 2 and 68. 68 we split up into 2 and 34. 34 we split up into 2 and 17. 17 being prime. So 136 equals 2 cubed times 17. We now draw a factor table with 36 and 136 on the left, 2, 3 and 17 across the top, because those are the factors that appear. Those are the prime factors that appear. So if any of these numbers are not prime, check your factor tree and your prime factorization, because something likely went wrong. So now we write the type of 2 that goes into 36, which we can see is 2 squared. The type of 3 that goes into 36 is 3 squared, and there is no 17, so we write a 1. The type of 2 that goes into 136 is 2 cubed. The type, there isn't a 3, so we write a 1, and the type of 17 is just the 17. So the highest common factor of 36 and 136 is the lowest number in each column multiplied together. So that gives us 2 squared times 1 times 1. So that's just 2 squared is 4 times 1 is 4. We use the same method for this question here. 216. We split up into 2 and 108, which we split up into 2 and 54, which we split up into 2 and 27, which we split up into 3 and 9, which we split up into 3 and 3. So we can say 216 equals 2 times 2 times 2, which is 2 cubed, times 3 times 3 times 3, which is 3 cubed. We now do the same for 144, splitting that up into 2 and half of 144, which is 72. We split that up into 2 and 36, which we split up into 2 and 18, which we can split up into 2 again, and 9, which we split up into a 3 and a 3. So 104, underline that just so we can keep track of it. 144 equals 2 times 2 times 2 times 2, which is 2 to the power of 4, times 3 times 3 is 3 squared. Now we draw our factor table with 144 and 216 down the left. The factors that appear are 2 and 3, so we write 2 and 3 across the top. And now we draw our table. The type of 2 in 144 is 2 cubed. The type of 3 is 3 cubed. For 216, the type of 2 is 2 to the power of 4. The type of 3 is 3 squared. For the highest common factor of 144 and 216, we pick the smallest number in each column, discounting the top row and the leftmost column. The type of the smallest 2 in the 2 column is 2 cubed. The smallest 3 in the 3 column is 3 squared. So that gives us 8 times 9, which is 72, which is the highest common factor of 144 and 216. That would be more of a typical exam style question. It would be very difficult to use trial and error for these numbers. And it would be very unlikely that even if you did use trial and error that you would come to the answer of 72. We now work out the lowest common multiple for 8 and 10. We use the same method of factor trees, only this time with the factor table we pick the biggest number from each column. So we know from a previous question that 8 equals 2 cubed and 10 is just 2 times 5. So now we can draw our factor table very easily with 8 and 10 on the left and 2 and 5 across the top. The type of 2 in 8 is 2 cubed. There isn't a 5, so we write 1. The type of 2 in 10 is 2, and the type of 5 is just 5. So the lowest common multiple of 8 and 10, the biggest 2 in the 2 column is 2 cubed, discounting the topmost and leftmost lines. The biggest 5 is 5, so we have 2 cubed times 5, which is 40. Without a calculator, you would do 2 cubed is 8, 8 times 5 is 40. We now find the lowest common multiple of 16 and 60. 16, skipping the factor tree method, because this is quite an easy one, though if you're unsure you should always do it. It's 2 to the power 4. 60 is 2 times 30, which is 2 times 15, which is 3 times 5. So 60 equals 2 squared times 3 times 5. We now draw our factor table with 16 and 60 down the left, and 2, 3 and 5, because those are the factors that appear all together across the top. Constructing the table and then filling in the type of each number that we have in each column and row. So the type of 2 that we have is 2 to the power 4 in 16. We don't have a 3, so we write a 1. We don't have a 5, so we write a 1. The type of 2 in 60 is 2 squared. The type of 3 is 3. And the type of 5 is 5. So we write 2 squared in the 2 column, a 3 in the 3 column, and a 5 in the 5 column. Discounting the topmost row and the leftmost column, we see that the lowest common multiple of 16 and 60, by picking the biggest 2, which is 2 to the 4, the biggest number in the 3 column, which is a 3, and the biggest number in the 5 column, which is a 5, 2 to the power 4 times 3 times 5, 2 to the power 4 is 16, 3 times 5 is 15. That gives us 16 times 15, which is 240. We now do 216 and 60. So we're seeing why the factor table method and the factor tree method is quite useful, because when it gets to bigger numbers, it is a real headache using trial and error. And if you use this method and you practice it, these questions become easy marks in an exam. If you know exactly how to get all the method marks, and as long as you don't make any numerical mistakes, you get full marks. So we saw in the last question that 60 is 2 squared times 3 times 5, so we can use that here. It's a handy exam tip. Sometimes in exam questions, your previous answers give you clues, particularly if it's split up into a part A, a part B, etc., or a part A, part 1, and then A part 2. The answers are often linked, especially if a question says hence. If a question says hence, then the answer to the previous question is always linked. If you cannot answer the previous question, but you think you can answer the next part of it, you are allowed to just make up an answer for the previous question. Pick any number you want, say whatever the question is, say 10, and use that. So write 10 in the previous question as the answer, and then use that in the next part, and you will get error carried forward marks. You won't get any marks for the previous question, but you may get marks for the question that you are using 10 in. So you don't necessarily have to lose marks if you can't answer the first part of the question. You can just make up an answer to the previous part and go with that for the second part. Not many people know that, and it's a very, very handy exam tip. So, we said that 60 was 2 squared times 3 times 5. $216, we'll have to figure out. That would be 2 and 108. 2 and 54. 2 and 27. 3 and 9, which is 3 and 3. So 2 cubed times 3 cubed. We now do our facts table with 16, 216 down the left. And 2, 3 and 5 appear here, 2 and 3 appear here, so we write all of them that we can see, which is 2, 3 and 5. And we then construct the table. I would also strongly recommend using a ruler for this in an exam. You don't want it to look sloppy and lose marks because the examiner can't read your answer. So always try and make sure that things are neat in an exam, and use a ruler wherever you can. So the type of 2 in 16 is 2 squared, the type of 3 is 3, and the type of 5 is 5. In 216 we have a 2 cubed, 3 cubed, we don't have a 5 so we write a 1. We then discount the leftmost column and the topmost row. And for the lowest common multiple of 60 and 216, we pick the biggest number in the 2 column, which is 2 cubed, the biggest number in the 3 column, which is 3 cubed, and the biggest number in the 5 column, which is 5. So that gives us 2 cubed, which is 8, 3 cubed, which is 27, times 5, which gives us 40 times 27, which is 1080. Lastly, 420 and 144. So let's see if we've found either of these before. 420 and 144. We know 144 is 2 to the power 4 times 3 squared. 2 to the power 4 times 3 squared, and I don't think we've found 420 before, so we'll have to work that out. So 420 goes to 2 and 210, which goes to 2 and 105, which goes to 5 and 21, which goes to 3 and 7. So 420 equals 2 times 2, which is 2 squared, times 3, times 5, times 7. For our factor table, we write 144 and 420 across the left, and across the top we write down all the factors that appear. So 2, 3, 5 and 7, 2 and 3, so all the factors are 2, 3, 5 and 7. Remember, if a number appears in either of them, you write it across the top. we'll just move the 420 down to give us a little bit more room. If we can. If we can't, never mind. So we now construct the table and fill it in. The type of 2 in 144 is 2 to the power 4. The type of 3 is 3 squared. There isn't a 5 or a 4. There isn't a 5 or a 7, sorry, so we just write a 1. In 420, we know there is a 2 squared, a 3, a 5, and a 7. So now discounting the leftmost column and the topmost row, and multiplying together the biggest number in each column. So the biggest number in the 2 column is 2 to the 4, the biggest number in the 3 column is 3 squared, the biggest number in the 5 column is 5, and the biggest number in the 7 column is of course 7. So we have 2 to the power 4 times 3 squared times 5 times 7. We now multiply all of these together. Now if you did get a sum this big in an exam, you would always have a calculator. You would never, or extremely rarely, be required to work this out without a calculator. And the answer is very big. It is 5,040. Moving on to the last question, which is a problem-solving question. There will be another video coming soon for a problem-solving worksheet for highest common factor and lowest common multiple. For now, this is the type of problem-solving question that we'll be looking at tackling. You can expect to see a question like this in Foundation and GCSE Mathematics. The next problem-solving video, you will only be expected to do those questions, in my opinion, in a higher paper. I think they'll be too difficult for Foundation. However, this question I think would be reasonable to ask for Foundation. So you're waiting at the train station for your train to London. Your train arrives at 10:30 AM, and you notice another train arrives at the same time which is heading to Glasgow. The train to London arrives every 22 minutes, whereas the train to Glasgow arrives every 18 minutes. What time would both trains be at the station again? So there's a lot of words in this question. So what we need to do with wordy questions is pick out the important information. It doesn't matter that you're waiting at the train station. It doesn't matter, really, that the trains are going to London or Glasgow. It doesn't even matter that they're trains. What matters is the numbers in the question. 22 minutes and 18 minutes. And also the time will be relevant as well, because we want to know what time both trains will be at the station again. So, the train to London arrives every 22 minutes, and the train to Glasgow arrives every 18 minutes. And we want to know when they'll both be at the station again. And then we know that they're both at the station at 10:30. So what we're looking for is the lowest common multiple of 22 and 18. Because the next train heading to London will arrive at 10:52. And the next one going to Glasgow arrives at 10:48. So we're going up in 22s and we're going up in 18s. So we need to find the lowest common multiple in order to solve this question. So we write them both as a product of their prime factors. 18 goes into 2 and 9. 2 and 9 make 18. 3 times 3 is 9, so 18 is 2 times 3 squared. 22 we split up into 2 and 11. 11 is prime, so we circle it. So then 22 equals 2 times 11. We now do our factor table. So 18 and 22 go on the left, 2, 3 and 11 go across the top. And so now we draw the table and fill it in. So the type of 2 in 18 is just 2. The type of 3 is 3 squared, and there's no 11, so we write 1. The type of 2 in 22 is just 2. There's no 3, and the type of 11 is just 11. So discounting the leftmost column and the topmost row, and then finding the biggest number in each column gives us the lowest common multiple of 18 and 22 as 2, which is the biggest number in the 2 column, times 3 squared, which is the biggest number in the 3 column, times 11, which is the biggest number in the 11 column. So we have 2 times 3 squared times 11, which gives us 198. But we're not quite finished. This is a word question. Usually our answer has to have some context. 198, what does that mean? What have we worked out? Well, the 18 and the 22 are times in minutes. So this is 198 minutes. But we need to read the question again to check, is 198 minutes the answer, or do we need to do something else? Well, it says, what time would the trains both be at the station again? 198 minutes isn't a time on the clock, it's just a period of time. We see that the train arrives at 10:30 AM, and we know that the next time both trains will be there is 198 minutes later. So we need to work out what is 198 minutes later than 10:30. So first we need to calculate how many hours are in 198 minutes. Well, there's 60 minutes in 1 hour, 120 minutes in 2 hours, and 180 minutes in 3 hours, with 18 minutes left over. So we know there's 3 hours and 18 minutes. If we add that on to 10:30, we get 13:48 as our time. So that's the end of our worksheet solutions video for the prime numbers. There'll be a problem solving one coming soon, which will be applicable to the higher GCSE. But for now, thank you very much for watching, and if you'd like to do the worksheet yourself and find more worksheets, revision sheets and videos, please head over to prioritylearning.co.uk. Thanks for watching, and see you next time. Please don't forget to like this video if you found it useful, subscribe to the channel for more videos, click the little notification bell so you get notifications every time we make a new video, and please share this on Facebook, Twitter, and even email. Share it with your friends to raise awareness for the channel, then we can reach more people. Thanks again for watching, and goodbye.